Okay, leaning. I'm going to breeze through this a little bit since it's not that complicated, and really it's just a matter of linear interpolation of the camera. If that sounds confusing, then it's okay, I'm going to explain it to you. So we start in the player scene over here, and what you want to do is you want to have two export variables, like these ones here, camera base position and camera lean position. And what we're going to do is a camera base position is going to be where you want your camera to normally be throughout normal play of the game. So in this case, this is 0x0z and 1.5 meters up. So that would be here. Our lean position is where we want the camera to be at the end of our leaning action. So in this case, that's 0.75 on the X and 1.4 on the Y. So a little bit over and then a tiny bit down. If we actually do that, that would look like 1.4 and 0.75. Yeah, so you can see it's just a little bit over and a little bit down. So with those two things set, let's take a look at the script. We want to go to the top here. So you can see this is where these two export variables are set. And then the other thing we need is this constant here, lean lerp. This is the weight we're going to use for our linear interpolation. So if we go down to handle leaning here, this is the function that makes all this work. So you can see it passes in delta. This just gets run in the process function every frame. So let's just take a look at that quickly. Yeah, you can see here. So we do our leaning, our head bobbing, and all of that stuff here. So we go back to the function. Yeah, here we go. So it starts with basically the conditions under which we don't want the player to be able to lean. So for me, that's certain tweening actions, mostly when the player is either climbing or like during their climbing action, or when the camera is moving down to crouch. Those are the two instances in which I don't want the player to be able to lean because it could cause some weird behavior to happen. I also think it's weird to be able to lean in water. That's just me, so I don't really do that. And for my game, I don't want them to be able to lean while moving because I find that looks strange, but I might change that later. So next we set this variable here, which is basically the point that we want our camera to stop leaning under certain circumstances. I'm going to explain that in a bit, but first I'm going to demo it without that. And then we have action strength here. And action strength is how we decide where to lean. I'm going to expand this out. So what we do is we get our two leaning inputs, basically. So I'll show that off. If we go down, yeah. So I have Q and E bound to lean left and lean right. And what we do is we get the action strength, which for keyboard inputs, this is basically, this will return 0 if the button isn't being pressed, and 1 if it is being pressed. So what we do is we multiply what we get off that. Hey, just making a slight addendum to the video here because I realized the way I was doing this action strength was wrong in post. You don't actually have to do this multiplication by -1 thing here. All you do is you do right first, and then you do left afterwards, change this to subtract, and then just get rid of this, and this will work exactly the same, but you don't have to do any multiplication or anything. It's just a bit of neater code. Thought I'd throw it in there. Yeah, let's move on. And what that gives us is it will always be either -1, 1, or 0. So if we're not pressing it, or we're pressing both, it will be 0. If we're leaning to the right, it will be 1. If we're leaning to the left, it'll be -1. And I'll just briefly show off how this works by running this. You can see we're printing out action strength here. So if we run this, you look in the bottom left there, yeah, you can see it's printing 0 because we're not leaning. If I lean to the right, it becomes 1. If I lean to the left, it becomes -1. And that's important for what we're going to do next. So, if our action strength isn't 0, so if we are leaning, we set is leaning to true. And just ignore this for a moment. I'm going to explain that later. This here or basically both of these statements here, they're both the same thing. One's just for if I'm crouching. These are the thing that actually powers this. So linear interpolate, if we look at that function, returns the result of the linear interpolation between this vector and b by amount t. T is on the range of 0 to 1.0, representing the amount of interpolation. So you can think of this as just moving between two given vectors by a set weight. You remember that leen lerp constant we defined earlier? That's our weight. So what we do is we interpolate on the camera transform origin, not global transform. We want to be using just transform for this. And then we multiply our leen limit by our action strength. And our leen limit in this case is our camera leen pos.x. You remember that 0.75 from earlier? It's that. We multiply that by our action strength. So that will either be -1 as into the left, or 1 as into the right. So it will move our camera from the left to the right depending on which input we're pressing down. Then we move our y down, and then we move our z, which I believe is 0 on this. It doesn't actually do anything, but it has to be a vector 3, so we need 3 inputs. Then we put in our leen lerp, and we multiply this by delta. You need to multiply this by delta to make it independent of the frame rate. Because otherwise, if you didn't do this, someone who was running at 200 frames would lean a lot quicker than someone who was running at 10 frames. And again, this is just the same statement here, just for if I'm crouching. Then what we do is we lerp, so lerp just moves a floating point variable, not a vector 3. And we lerp the rotation degrees z value. So this, well, you can see it if I run it. You'll be able to, so if I lean, you can see that we're kind of tilting over a little. And that kind of gives the impression of the player kind of tilting their head. And I'll show what that looks like if we turn it off. Comment that out. You can see it's a bit more static, right? It doesn't feel as genuine. So yeah, that just makes it look a bit nicer. Yeah, and all we do here is we just we basically take our rotation degrees.z, which will be 0 when it starts. We are lerping to 5 degrees multiplied by our leen limit, plus a little bit just to make it look a bit better, and then we multiply it by our negative action strength, because if we multiply it by our positive action strength, it looks wrong. Don't ask me why. Vector math, it irritates me. And then again, leen lerp times delta to make it frame independent and all that. Yeah, so again, if we demo this, you can see it looks pretty good. It feels reasonably natural. But we have a problem. Yeah, you see, we can just lean straight through the geometry, which is definitely not what we want, right? So how do we fix this? Okay, well that's this big block of stuff here I've commented out, so I will now uncomment that, and we'll take a look at this. So you can see it's making a bunch of references to a leaning rays array. So if we go back up to the top here, we can see, where is it? Leaning rays array. So it gets the children of a spatial here. So if we unexpand this and we go back into 3D, and where is this? Yeah, here it is. That took me a moment. Okay, and you see we have 6 rays here. And the way these work is they basically point from the opposite side to which we're leaning. So you can imagine this is one of our lean left rays, but it's on the right side here. And we do that because we don't want to risk this ending up inside the geometry. We always want to be pointing from the outside of the geometry into it, because otherwise we won't actually get any collision. So we point from the opposite side, and we go straight over, just a bit out of the collision box, so we've got some buffer space to figure out where we should stop. And we do 3 of these for each direction we can lean in. And I'll explain why we do 3 later, but for the moment, if we go back into handle leaning, there it is. Yeah, so what we do is we get our action strength and we decide which set of rays to turn on because there's no point in having all the rays turned on all the time. It's just a waste of performance. So what we do is, based on our action strength, we turn on either our set of left rays or our set of right rays. And you can see that here. This is just so we don't have to write a bunch of code twice. Whoops. Then, I'm going to expand this out again. Then, yeah, here we go. So what we do is we go through each ray, front to back, and we basically check if there is a collision point. And if there is, we set our lean limit to that collision point. Then we do that for each ray, checking if each ray has a collision point that's closer than the last one. So you can see that here. We get our distance 2, and then we check if this dist value here is less than our current lean limit. Then we set that to be the lean limit minus 10% of our distance value. So that gives us, we always have a little bit of buffer off the wall, because otherwise our we would basically lean right up to the collision point with the wall, and that would like be slamming our face into the wall. Like it would just look strange. And yeah, that's how we stop ourselves from clipping through the geometry. So if we run this again and we walk over, you can see stops me, won't let me do it. No matter what I do, can't get through it. Yeah. Now, why do we have 6 of these? I'll explain. So if we go back into the script, and let's actually turn off 2 of these. So the front and the back ones. Actually, no, it'd be easier just to do that. Yeah. And let's make it so we can lean while we're walking. So, oh, I still can't lean while I'm walking. Okay, well clearly I was very good at making sure the player can't do that. But anyway, I can still demo. So, you can see what's going to happen is we kind of get very close to it, and then we clip through the wall briefly, and it just looks kind of terrible, right? And if you were able to walk while leaning, this would be way more obvious, and you can even get some weird stuff here where I'm not quite sure what's going on there, but it's not supposed to happen, and it doesn't happen with my fix. So that's the reason we have 2 extra to check. So we're checking a little bit in front of us and a little bit behind us to make sure that if the player is doing some weird stuff like this and they're trying to, you know, well, they're basically putting themselves in a position where they could look through the wall, the game stops them. So they can get very close to the wall and they can still lean around it as normal, but when they're doing this, the game looks a bit ahead and stops them from clipping through the wall. Now, there's one last thing I want to clarify. Well, it's why do we use linear interpolate here instead of an animation player or a tween? And I'll explain that. The reason I like to use this compared to an animation player or a tween is mostly because of how it feels. It's very difficult to interrupt tweens while they're running. You can do it, but it tends to make some messy code. You can interrupt animation players as well, but then what you're doing has to be a lot more fixed, right? It's difficult to make this dynamic. So that's why I use linear interpolate, because if I go back in, if I just tap, you can see I lean over a little, and then I come back, and it does that for whatever direction I'm going. If you play Dishonored 2, they changed it so that you have to complete this action, and then uncomplete it to actually do leaning. And that really frustrated me, because if you look at older stealth games like Deus Ex or Thief, they do it how I'm doing it here, where you tap and you just kind of lean over a little bit. If you hold it down, you lean over all the way. And to me, this feels more natural. But yeah, it's entirely up to you. Okay, and the most important part of this is actually leaning back again, and this is a little bit messy because I could export action strength to be global variable, and this would look nicer. But the gist here is that pretty much if we're not leaning, then we want to move the camera back to its camera base position here. See? That's why we defined that earlier. And this here turns off all the rays. This, like I said, depending on whether or not we're crouching, returns us to a given base position. And then this down here is just, like it says here, it's a separate branch I made to deal with a bug I was encountering while I was head bobbing. But all it really does is it just lerps the camera rotation back to where it should be. So you remember that Z rotation we did? This just moves that back to be right. Now this here, what this does is you'll notice with linear interpolation, if you use it, that it tends to, as it gets closer to its target, it increments in smaller and smaller steps. And I can show this actually. If you look at the top left there where you see the rotation, if you look at the end of that, that will be the Z value. As I lean, you can see it gets smaller and smaller and smaller and smaller. So now we're up to 4.9999995 or something, and it'll just slowly tick towards, well, 5, which is what it should be. But if I then now let go, you can see it gets to a certain point, then it snaps back to 0. And that's kind of what I want. I haven't implemented that yet for leaning towards 5 because I'm lazy, but yeah. But this isn't critical, to be honest. I just do it because I like my numbers to not be hanging tiny floating point values, because, I don't know, I just like to be neat. But yeah, I don't think there's anything else left to go over, so yeah, I hope this was helpful.